polynomials can have more than one variable in them, okay? Now, the way that you find the degree of a polynomial that has more than one variable is you look at the sum of the powers in each term. So in the first term, I have a squared and a third power. Altogether, that comes out to be a total of a fifth degree term. The second term has a 4 and a 2, so that gives us 6 for our degree there. So every year I put this on a test as a freebie question, what's the degree of the polynomial? And we always forget what to do because we don't pay attention to this little bit right here. So how do you find the degree when there are several variables? You add up the degrees of each term, and that's how you get the degree of the polynomial in total. So this one, since the degree is 6, that's the biggest one. That makes this a 6th degree polynomial. Even though there's nothing up there that actually has a 6th power, that's the total power of a single term, okay? Now, we can multiply things that have multiple variables, no problem, exactly the same way that we multiplied anything else. So we have x times 3x, that's 3x squared. X times 5y is just going to be minus 5xy. Then we have 4y times 3x, that's 12xy. We always write variables in alphabetical order within a term. And then the last one gives us minus 20y squared. We want to make sure that we put the variables in alphabetical order because it makes it really clear when we have like terms, which we do in the middle. So we end up with 3x squared plus 7xy minus 20y squared. And that would be the answer there. Number 8, we're squaring a binomial. We can do this exactly the same way we've done everything else. Square the first, so that's going to be 25x squared. Square the last, that's going to be 9y squared. Multiply is 15xy. And double, so we get plus 30xy. And this should be a plus, okay? Now, we can take some shortcuts if we recognize special products. And you don't necessarily have to do them this way. This is definitely not like a hill to die on, but if you catch it, it does make it a little bit simpler sometimes. So what we want to be looking for is either being able to use the difference of squares or being able to square a binomial. None of these are two-term polynomials though, but we can group them. So what I see is that I have 7x plus 5 in both of them, and then the only difference is a plus 4y and a minus 4y. So if I group these by adding some extra parentheses right here, I now have an a plus b, a minus b kind of situation. This is the case where I think this is the easiest and the biggest time saver. Because remember, when we multiply conjugates like this, the answer comes out to a squared, so that's 7x plus 5 squared, minus b squared, so that's 4y squared. Well, we know how to do both of these things. 49x squared plus 70x plus 25, and then we have minus 16y squared, and none of those are like terms, so that is our answer. Think about if we had not done it that way, we would have had to do 7x times 7x, 7x times 5, 7x times negative 4, 5 times 7x, 5 times 5, 5 times negative 4y. So it would have been a much longer process, doable still, but you would have had to distribute out 9 things. Instead, we caught that this follows the pattern. Now, you could do the same thing here with this one and just create 2 terms. There's no rule for squaring a trinomial, but there is for squaring a binomial. I might add an extra set of parentheses right here, okay? If we think about what this would do, we now have like an a plus b kind of scenario. And we're squaring that. Think about what that comes out to. Square the first, square the last, multiply, and double. So that's what we have. But the way that I've defined it up above is that A is 3x and B is y plus 1. So I have 3x squared plus 2 times A was 3x, B was y plus 1, and then I have plus B squared, which would be y plus 1 squared. So again, still a lot of multiplying out to do, but none of it is as ugly as if I wrote it out side by side and had to distribute 9 times. So we would get 9x squared plus, this is going to be 6x, and then if I distribute that, I get 6xy plus 6x. And then this is going to be y squared plus 2y plus 1. Square the first, square the last, multiply and double. None of those are like terms, and so that's our answer. Do you have to do them this way? No. But again, it's a kind of a situation where we need to move from accuracy to efficiency. Not just can we get it right, but can we get it right quickly? And these are some little tricks that we can use with our special products to make this process go a little bit more quickly.